Hey everyone, welcome back to my channel Code in Code, and from today onwards we will be starting the AWS series which was declared yesterday. And in this AWS series I will be covering from scratch everything about the AWS services, everything about the cloud computing, what cloud computing exactly is, why should you go for opting the cloud services nowadays, and what is the importance of it, what are the benefits of using the cloud services, and everything will be covered in this particular series. So if you are a beginner and wants to learn the cloud services, definitely it's a good place to start with your journey. And since AWS is something which has a major stake in the cloud service providers in the market, so you should definitely consider learning the AWS service. And apart from that, there are also major services which are there in the market, like the Microsoft Azure and the Google Cloud. So definitely you can learn these cloud services too. But in this particular series I will be teaching about the complete AWS series from 0 to 1. So everything required to get started with AWS will be covered right into this video. But for the today's video, I will be covering about what is cloud computing. So keeping this in mind that there will be folks who are beginners and just want to start with the AWS services and wants to learn the cloud computing. So cloud service is something which everyone should know. Even a DevOps engineer has a good knowledge of the cloud services. So cloud service is mandatory wherever you go for the any service related to the any sector related to the cloud. So cloud services is very important to learn. So in this today's video we will be covering about what is cloud computing and everything related to it, types of the cloud deployment model, IaaS, PaaS, SaaS, everything will be covered into this video. So stay with me till the last. Everything will be covered from scratch, and I will try to make it as much easy as I can, and I will try to use easy terms and also make you understand the complex terminologies with the easy examples. So without further ado, let's get started. Before starting, if you haven't subscribed to this channel, make sure to subscribe to this channel and press the bell icon so that you can get all the updates right away when the video will be launched. So coming to the slides, so what is cloud computing? So in this particular series we are learning cloud computing with AWS, and this is completely from 0 to 1, and this is a lecture 1 of this AWS series. Regularly the videos will be coming around the AWS. I will complete this series. Moving to the what is cloud computing. So cloud computing, what is the need of cloud computing? First the question should be that should be in your mind. So what is cloud computing? So before understanding cloud computing, understand what used to happen when there was no cloud computing, when there was no concept of the cloud computing. So in the 90s, before 2010, right, before 2010. So when there were any startup or the companies, they used to have their own on-premises server, have their own infrastructure to manage all the servers, have to manually scale up and down based on the requirement. Suppose you have built a website, right? And to build that website, you require the servers, infrastructure, and infrastructure includes the cost of the storage and the people, to train in the field of the IT so that they can manually scale up and down. So basically, lots of cost was involved when you have to build on-premises infrastructure. Right, I'm talking about on-premises means wherever is your office, there is an infrastructure at the same place. So you have your own data center, you have your own servers where you can store your data and give network access to the whole world to access your particular service, right? So all these costs were involved in the on-premises. You have to even give an overhead cost to train the people to use that particular infrastructure, to train them on how to use that particular hardware, so the software. So lots of costs were involved. Then slightly around 2010, the concept of cloud came, right? And when concept of cloud came, there's a plan to shift everything from on-premises to the cloud. What does that mean is, now you have to don't care about anything like purchasing space first you have to purchase a space where you can build your infrastructure, building the servers, storage, and training people around the IT field to use that particular servers and maintain that infrastructure which you have built. So everything was moved to the cloud. Now it's not your responsibility to maintain the infrastructure. You don't have to worry about scaling up and down based on the requirements and the user traffic which is coming to your application. You just have to see the scaling of your application. How can you scale your application? So everything was removed from your head, right from maintaining all that infrastructure, buying the space, maintaining the space, training the people. Everything was reduced and everything was shifted to the cloud, right? So in this manner, everything was reduced, the space was reduced, the cost was reduced, and everything became reliable. There was no crash on the servers because everything was maintained on the cloud. And cloud is, we will discuss this further, that cloud is very flexible, very elastic, it is very fault tolerance. It can handle the fault even what if all of your data will be lost. So in that case you will have to face a huge loss, right? But in the cloud services there is a system of the backup, so you don't have to worry about the loss of your data. Either or the some way you can get your data back from any of the data centers around the world which are there. We will talk about that too. So in a nutshell, cloud computing is giving the on-demand resources. Suppose you have built a website and on the first day only 20 to 30 users are coming to your website. So in that case you will be allocating less resources, and on a certain day you see that lots of traffic is coming to your website, like 1000 to 2000 users. So in that case the servers or the infrastructure or any type of resources which were there for the 30 people will not be adequate for the 2000 people who are coming all of a sudden. So in that case cloud take care of all these things. They can scale up and down based on the number of users which is coming to your website. So it is cloud computing is a concept of providing on demand availability of the computer resources or the system. You don't have to purchase any sort of high processing computers or the supercomputers for storing your data or for the servers and all that. So availability of the computer resources, especially data storage, computing power, without direct active management of the users. So this is an important point. Everything is automated as of now. You don't have to employ your own people to maintain that infrastructure. In this case, only the people who are specialized in the cloud will be managing your infrastructure in the backend. So you don't have to worry about maintaining all those servers, hardware, spaces. Don't have to worry about anything. Then large cloud often have function distributed over multiple location. Just now I have discussed, they have multiple data centers all over the world. Like for the AWS they have multiple data centers. We will be discussing in the upcoming lecture, maybe in the lecture 2 or 3. I will be discussing about what is availability zones, what is regions, everything will be discussed. Then each of which is a data center, we call it a data center, which is a very important concept. Moving forward, why should someone go for the cloud computing? What is the benefit of using the cloud computing? So using cloud computing has multiple benefits, some of which are mentioned here. Lower computing cost. Obviously you don't have to pay overhead. If you are using less resources you have to pay less, and even if you are using more resources you have to pay only for that resources which you are using at that particular moment of time. So in this way you can do cost saving. So lower computing cost, then improved performance. You don't have to worry about the elasticity or scaling of your platform, or when the traffic is coming or when the traffic is reduced in your platform. Then reduce the software cost. Then you don't have to worry about any sort of software because everything is being managed by the cloud providers itself. We will talk about what cloud providers are, cloud service providers are. Everything will be discussed in the upcoming lecture. So every terminology which I will be using, I will be telling you about that too, right? So then the instant software update, you don't have to even worry about installing or updating the software regularly. Everything will be taken care by the cloud providers itself. Then increase the data reliability. There is less chances that data will be lost, and even if there will be loss of the data, they can be recovered in most of the cases because they have multiple data centers, because your data is not stored at one location. Your data is distributed across multiple data centers. Data center is just like a place where you can store your data. And for AWS, since AWS is a very huge service, and even the various cloud providers like the Microsoft Azure services, then the GCP are large cloud providers. They don't have any one data center. They have multiple data centers distributed across the world. So you don't have to worry about loss of your data. There is fault tolerance. It can handle the fault tolerance. In fact, then there is unlimited storage capacity. You don't have to worry about purchasing new hardwares. Not hardwares, hard disks to store your data into. Everything will be done on the cloud provider itself. Then device independence and the always on thing. You don't have to worry about keeping your system on for usage of your particular infrastructure. So everything will be taken care on the cloud. The system will be always on. Your data is accessible 24/7. Then you can access it from anywhere in the world, right from, if I'm sitting in India and I want to access the data which is there in the South Africa, I will be able to get that data just with the help of the internet connection. So there is ubiquitous network access. So I will be discussing about that. What is ubiquitous network access? Then free from maintenance. Of course, you don't have to maintain the infrastructure and the cost of the servers or anything. Regular maintenance will be done by the providers, and you just have to pay pay for the infrastructure which you are using as rental service from the cloud providers, right? And let's talk about the history and origins of the cloud computing. When did it came? What is the history and how did it came? Right. So in 1996, there was some supercomputers on the mainframe where there were infrastructure and the servers were built upon, and they were managed with the supercomputers itself. Then in 1999, there was some cloud terminologies which evolved at that time. Then in the 2000, Amazon Web Services was launched, right? So it was the first cloud service which was launched in 2000. Then slightly in 2000 itself, the first service which was launched of AWS was Amazon S3, that is simple storage service, which is which is one of the most popular services offered by the AWS. Then at the same time, Google launched their services. Then there came the Azure, and like that all the services came around 2008, right? So this is the evolution of the cloud computing. How did it came? What was the origin and all that? Then moving to the evolution of the cloud computing, how over the years the cloud has evolved, and now we talk about moving all our services to the cloud. So how did it happen, and what used to happen before the existence of the cloud? So before the existence of the cloud, there were dedicated server. So what is dedicated server? That means one physical machine dedicated to a single business, right? You have a computer and you're dedicated. Suppose I have this computer in front of me. I'm dedicating this particular computer on all the resources and the hardware which are in my computer to a single business, and for no other purpose I can use this particular computer, right? So it runs on a single website. You can run only single web website. And of course, if you have multiple services for that one particular business, then you have to purchase multiple computers for the with the high configuration, and of course they will be very expensive, and there will be a lot of maintenance, of course, and you need a lot of security because there can be data breach at that time, and there can be a chance of the data loss or a hacked system or anything like that. So you have to spend a lot on the maintenance and the security itself. Then came the virtual private server, that is VPS. And at that time, so one physical machine was dedicated to a single business again, but the physical machine was virtualized into some machine. I mean, suppose I have this laptop. So on the top of this laptop, I have built a virtual system, and in the virtual, I can have multiple virtual system on that particular in that particular laptop itself, right? So now I can say that I have one physical machine dedicated to one single business. But now even after having one single laptop, I am having virtualized operating system. What does that mean is, suppose I have a Windows laptop. On top of it, I can also use different operating system without letting know this operating system of the original operating system, right? So we say that this is virtualized. Why? Because you are building it on the top of an existing virtual operating system. So we call it virtualized, right? So it has a better utilization, and there were isolation of resources. Why? Because they were mostly operated with the Linux, so it was it has a very good security itself. So it was isolated from all of the resources. Then there came the shared hosting. In shared hosting, you can understand it is a shared related to something sharing with someone. So one physical machine, but that will be shared with hundred of businesses. I have this laptop, but with this one laptop, I will be managing hundreds of businesses, and which relies on most tenants underutilizing their resources. Suppose I have purchased the laptop and my usage is not up to the mark of this configuration, right? So in that case, there is a loss. I'm not able to get the ROI, return of investment. I have invested a lot on my laptop, and the configuration are not getting used onto that level. So there is a loss of investment. I will not get the ROI, proper ROI. So it is very cheap and with limited functionality, and there has a poor isolation. Why? Because hundreds of services are being operated in the same computer itself. Then there came the robust service, which is the cloud hosting. So cloud hosting is till yet the most popular service which is being opted worldwide, and in which the multiple physical machines that act as one system. There are multiple physical machines, multiple computers which are acting as one system. They are storing lots of data. They are managing lots of servers. They are managing lots of traffics which are coming into their particular system. Right? It is very flexible. You can it is very scalable, secure, cost effective. We will discuss all these points in detail. What do I mean by flexibility, scalability, secure, cost effective, high configurability? What does it mean? That means it's up to me how I want to configure my particular service, when service I want to use and where to use. It's up to me how I want to use that particular service. It's totally up to them, totally up to me. Then coming to characteristics of the cloud computing, what are the characteristics of cloud computing? So it provides the on-demand self-service. Obviously, I have discussed this earlier. It provides on-demand whatever the resources you need. You can tell them right on the time of the usage. Then there is a resource pooling. I will be talking about what is resource pooling, and then there is a broad network access. Then you can access it from access it worldwide, from anywhere and to from anywhere to anywhere, like I'm sitting in India and I want to get the server which is situated, or the data center which is in the US. I can definitely get that. Then there is a rapid elasticity. I will talk about the difference between the elasticity and the scalability just in the upcoming slides. Then measured service. So these are the major 5 characteristics of the cloud computing. So there are other than 5, there are lots of characteristics, but these are the 5 major services. Now let's talk about each of them in a detail. So talking about on-demand self-service, so I have discussed it earlier. On-demand self-service is a key characteristic of the cloud computing that allows users to independently access and manage computing resources. So it's up to you how you want to manage, what services do you wish to use for your particular application. Everything is up to you. What the cloud providers will do once you have taken that particular service for the pay as you go model. I will discuss about these models too. So they will be maintaining that particular services, right? So it's up to you which service do you wish to use for which purpose. So it's a key characteristic of the cloud computing that allows users to independently access and managing computer resources without requiring human intervention. So servers or the storage will it is scalable, and it provides a dynamic scaling, and that dynamic scaling is known as elasticity. I will talk about elasticity in the next slide. So for that, for now, just understand the term dynamic scaling. Dynamic scaling means you don't have to worry about scaling it manually. whenever there will be need of the resources, or whenever there will be need to reduce the number of resources which are allocated, it will be done automatically, and at that time we can say that it is a dynamic scaling, and dynamic scaling is known as elasticity. That's a simple, right? So I was talking about the on-demand self-service. So it provides a ubiquitous network access. Ubiquitous means anyone can access it from anywhere in the world, right? So it provides a ubiquitous network access. Then resource pooling, advanced virtualization, where you combine combine multiple resources and use that for single purpose. Then in that case we call it resource pooling. So it provides advanced virtualization. It is something I will discuss it in the upcoming slides. Then it provides rapid elasticity. Elasticity I have discussed it earlier. Dynamic scaling, in short term, dynamic scaling is known as elasticity, right? And what is scalability? When you have to manually scale up and down, it is known as scalability. So scalable and elasticity are two different terms. Don't confuse between the two, right? Then it provides the flexible pricing, pay as per use. You don't have to pay overhead. You don't have to pay for the services which you have not used. You only have to pay for the services which you are using for that time. And there is a hourly model or the second model. That is something we will discuss when we will start with the AWS services. Then we will talk about the resource pooling, which is a very good term. So resource pooling refers to the practice of combining and sharing resources across multiple individuals, right? So there are lots of resources. I have lots of multiple pieces. I'm combining them and sharing resources across multiple individuals. I'm giving them to multiple individuals for the use, so that I can there will be flexibility and there can be scalability, right? You don't have to worry about the storage or the managing of the data and all that, right? So it provides the efficiency. Obviously when you are combining multiple resources, obviously it will provide the efficiency that is needed. Then it also provides the cost saving. Why? Because you have multiple computers. Then rather than buying a new system for the system which requires higher configuration, we are just combining multiple resources and using them as one. Then it provides scalability. I have also explained earlier what is scalability. When you have to scale up and down manually, it is known as scalability. Then it provides flexibility. Then it also mitigate the risk. Why? Because you are combining multiple system to act them as one. So it will mitigate the risk of the data loss at that time. So the resource pooling is a very good characteristic of the cloud computing. Then is a broad network access. You are sitting at your home and you are accessing the data which is present at the data center present in the US or the Mumbai or anywhere, right? So it is a fundamental characteristic of the cloud computing that enables ubiquitous access to cloud service over various network channel. It provides a device compatibility. Why? What does that mean? Device compatibility. Device compatibility means I can use it in my laptop or the PC or the tablet or anywhere. Then it provides network connectivity. What does network connectivity means? That it means that I can connect it via internet or the router or the LAN or anything. Anything is possible. Then location independence. You don't have to worry about storing the data at a particular place. It can be stored worldwide or anywhere in the world, right? Then it provides a multi-tenant architecture. That means multiple businesses can use your resources which are stored in the cloud. Then it provides a rapid elasticity, which is one of the very important concept or characteristic of the cloud computing. It provides rapid elasticity, which means that cloud computing that enables a dynamic scaling, which I was talking about. It provides dynamic scaling of the computing resources to meet the changing workload or the demands, right? So what are the characteristic? The root characteristic on-demand resource allocation. It will not allocate the resources by itself. You have to allocate the resources manually. So manually, or you can just say the cloud service to allocate it for you. It will do it for you. So on-demand resource allocation, it will not do anything by themselves. Then it provides automatic provisioning. Suppose you require 5 or 6 virtual machine, and on a certain day you have to scale it to 10. It will automatically do it for you with your consent. Then it is highly scalable. Then it is pay as per you use model. I have already mentioned it. The term explain itself. itself, like pay as per use. So you have to pay only for what you use, and it is a time and cost saving. You don't have to worry about anything. You just have to sit and operate everything with your just with the tap of your computer, right? Then it provides continuous availability. It does not have any latency. It has a very low latency. There is a very low downtime, I must say, right? It rarely goes down because there are lots of losses which occurs when there is a downtime on your particular platform. So AWS or any cloud services takes care of this thing on a priority. Then the last one is measured services. So measured services is a characteristic of the cloud computing that enables the monitoring, control and reporting of the resource uses to facilitate. Measured means, you can understand by the term, it provides the details of each and every services which is being used at that time. It provides the billing cost and gives the data about the usage of your particular service. So it provides the transparency, billing and optimization. It also helps in reducing the cost of the particular service which you have used. So resource monitoring, usage tracking, cost transparency, which is there in the measured services, and it is provided by the cloud services itself. Then it provides the capacity planning. You don't have to worry about how to manage or plan the capacity of your platform. It will do it for you. Then billing and invoicing, everything is done with transparency. Everything will be conveyed to you right before scaling up and down. Then what are the benefits of using the cloud computing? So it is very cost effective, right? So why it is cost effective, I have explained a lot of time. You pay for what you consume. There is no upfront cost, there is no overhead cost. This is pay as you go, pay G, we call it pay G, right? And thousands of customers are sharing the cost of the resource, right? And then global, it is available worldwide, so it is global. Then it is highly secure because multiple layers of security has been enabled. There is something IAM, which we will be discussing it, identity access management in the upcoming slides. Then it is very reliable. It is a data backup, disaster recovery, data replication. What is data replication? That means your data is replicated, copies are being made for your data and stored in multiple data centers. Why? Because someday if your data get lost, you can recover it from the different data centers on which data is stored, or replicated data is stored, right? So in this way it handles the fault tolerance, and there are many ways by which it handles the fault tolerance also. Then it is highly scalable. You don't have to worry about scaling up and down. It does automatic scaling with the help of the elasticity, automatic scaling during spikes and drop in demand. Everything has been taken care by the cloud service itself. Now, what are the types of cloud computing? So as I was mentioning, there are three types of cloud computing based on the services which are offered by the any cloud services. So majorly three services which are provided by the cloud are the SaaS, then second one is the PaaS, then third one is the IaaS. So the first one is software as a service. So what does that mean? So it means that you are using the software which is present right in front of your eyes. You are not observing what is going on in the back end, how the servers are being managed, how the application was built. Nothing you have to see. You just have to use that particular application. Some of the examples are like the thread which was just launched 1 to 2 days before, and it is getting very popular. It is the example of software as a service. Then there is something WhatsApp which we are using right now. Then there is something Gmail, Salesforce. All these are examples of the software as a service, because it is something which we are using directly. We are interacting it with directly, right? So a product that is run and managed by the service provider, it is being managed by the group of the people, like threads, and WhatsApp is being managed by the Facebook team, which is run by the Mark Zuckerberg. So you just have to use that particular application. Don't worry about how the services is maintained. It just work and remains available. It is as easy as it is written, right? Then comes the PaaS. So platform as a service. So this is just a triangle, right? This is just a pyramid which I have formed. So on top it is SaaS, under it there will be PaaS. So PaaS is platform as a service. It is basically meant for the developer, and SaaS is basically meant for the consumers, right? You just have to consume it or to use it, or you can see yourself as a customer, right? So PaaS is meant for the developers. So focus on the deployment and management of your app. You just have to focus on deployment. I mean, how to deploy the application. Suppose you have built an app, you just have to worry about where to deploy this application, how to deploy this application, how to manage your application. This is platform as a service, in which certain services is being provided by you, by the cloud providers, and certain initiative you have to take to manage those services on that particular services which is being provided by the cloud, right? Some of the examples are Heroku, VirtualBox, then AWS Lambda. All these services are example of the PaaS, right? Platform as a service, where some sort of application are provided to you. On top of it, you have to deploy your application. Right, and the last one is IaaS, infrastructure as a service. On the very beginning, I was talking about infrastructure as a service, infrastructure. So what does infrastructure mean? The server, the storage, the computing, the models, everything is provided by the cloud providers. So IaaS is something which is provided by the cloud providers itself. So basic building block for the cloud IT, provides access to the networking feature, compute, storage, everything is provided by the cloud providers. Some of the examples of AWS, GCP, Azure. You don't have to worry about the IT staff, data center and hardware. Right, so it is written in a very easy manner. You just have to consider it and try to write it down in your copy. Then let's talk about different services. So I have talked about the infrastructure as a service, IaaS, PaaS and SaaS. As of now, I hope that it is clear to you what does that three terms mean. And one more service which has been added up here is on-premise. On-premise is something, suppose you have built a startup and you are maintaining your servers by yourself, right? So basically, if you have an office, you have your data centers, compute, storage, everything is being maintained in your office itself. So on-premise, right? So I have mentioned it that this color represents the customer responsible for that, and the dark blue mentions that cloud service provider is responsible for that. So as you can see, in software as a service, everything is being managed by the cloud service provider. So what you have to do, you just have to use that application. So as you can see, cloud service providers has a major responsibility when you are using software as a service like the WhatsApp or the Threads application or the Instagram, Salesforce, Gmail or anything like that. When you are using platform as a service, major services are maintained by the cloud service provider, but some of the services needs to be managed by you, like the applications and data needs to be managed by you. Not everything is being maintained by the platform as a service. So it lies in the middle of the IaaS and PaaS. Then there comes the infrastructure as a service, in which customer is responsible for everything. Why customer is responsible? Because cloud providers are just providing you the infrastructure. You just have to go and build on top of that, right? So for the major of the services, you are responsible, like for the application, data, runtime, middleware, OS, and virtualization, server, storage, networking is managed by the cloud service provider. You just have to use that. Then in on-premise, you are responsible for all the services, right from purchasing a space, from buying all the servers or the compute, storage, networking, everything you have to take care by yourself. Nothing is being managed by anyone. So major responsibility comes when you are using the on-premises. So it's always preferable to reduce the cost, because lots of cost is involved in the on-premises, as you can see. So to reduce that cost, we are now just moving towards the cloud services. Now there are different types of cloud deployment models which are there in the market, like the public cloud, then private cloud and hybrid cloud. From the public cloud, you can understand that this is something which is managed by the service provider like the AWS, GCP, Azure, Oracle, IBM, DigitalOcean and all that, right? Then there is a private cloud. Private cloud is something which is solely managed by the organization. Suppose I have a good organization and I don't just want my share to be shared with anyone outside the organization. So at that case, I will build my own cloud, that is known as private cloud. Private cloud has a lot of expenditure involved in it. So if you don't have no very large budget, don't think for going for the private cloud. You can just move to the public cloud. Then there is hybrid cloud. So hybrid cloud is something, it is composition of the private and public. Suppose you have an organization and you want that some of the data should be accessed by anyone worldwide, and some of the data should be used by the people within the organization. So at that time you can use a mix of the cloud, like the public and the private. So basically there are three type of cloud services which are provided, like the public cloud, private cloud, and the hybrid cloud. So AWS, GCP, and Azure lies in which category of the cloud services, cloud deployment model? Take a second and think for it, then I will answer it. So the answer is it lies in the public cloud. Why? Because it is available worldwide. It is public. Right. If you are sharing any data and you just click on the share button, I can access it from anywhere. Like if you have uploaded a video on the YouTube or on the Google Drive, which is again a cloud based service, so you can just click on the share with anyone link and I can access that data. So at that case it is stored on the cloud. So AWS, Oracle, IBM, all these are examples of the public cloud, right? Now let's talk about the responsibilities which comes under this. So public cloud is very cost effective. Why? Because you don't have to worry about any infrastructure involved, any IT staff, data center, nothing is involved in that. Everything is managed by the cloud service provider, CSP itself. Then there is a lot of security control, then but sometimes it might not meet the security requirement which you are trying to meet. Why? Because there is by default lots of security which are already there, and there might be probability that you are not able to implement the type of services or the security which you want to implement on the top of it. Then there is very limited configuration based based on the what the cloud service provided exposes to you, right? So level of configuration will be very less. Why I'm saying this, because most of the services have been pre-built for you, just have to use it and deploy your application on the top of it. Then technical knowledge, you don't need to have a lot of technical knowledge. Like for the same private cloud, it is very expensive. Everything you have to build from scratch, right? Like right from buying the servers and everything is involved in the private cloud, and no guarantee it is secure. No, there is no fault tolerance. You have to spend a lot on building a very fault tolerant infrastructure in your private cloud. So you have to invest a lot of money for building a private cloud. Then you can configure the infrastructure however, like obviously it's up to you how you want to configure, what is the level of security you want to implement on the top of it. And for private cloud you need to know in depth, because everything is being managed by you. So you should have a very sound knowledge of the services of the cloud which you are building, right? You need to know in depth on how to configure all levels of your infrastructure, right from networking, compute, storage, everything is being managed by you. Now in the hybrid there is a shared responsibility. How a shared responsibility? It can be more cost effective based on what you offload to the cloud. Then you have to secure connection to the cloud and all that. Then you get the best of both worlds. Obviously you get the best of private and public. You get to use both the services, and obviously you need to have a good knowledge of the cloud. Why? Because it is hybrid. You need to have a knowledge of configuring the cloud services and which are there, right? Now this is up for the lecture 1. I hope you understand each and everything in this video. In the second video, we'll be talking about the total cost of the ownership, what is capex, what is what is opex. Everything will be covered, and how can you start with the cloud services. Then I will be telling about the basic cloud architecture terminologies like the availability, then the elasticity, scalability. We will be covering all this in more detail. Then also we will be starting on the basic cloud services. Like for this lecture I will be covering the AWS. We will be see the basic terminologies used in the AWS. What is AWS, how did it came into existence, everything will be covered from scratch. And in this video, if you feel any concept which which must be added, let me know in the comments so that I can add it in the next video. And if you have any doubts, feel free to drop it in the comments. I will share the particular slide in the comment itself, so you can access it from there. And if you like this video, don't forget to subscribe to this channel and press the bell icon, and also share the feedback of what are the videos you want in the upcoming days. And also don't follow me to forget on the social, and if you wish you can just tag me and start learning. So till then, stay tuned, make the notes for whatever I have taught you in this lecture, and lecture 2 will be coming probably regularly, and probably tomorrow. So stay tuned for that. Till then, keep learning and share your learnings with others.